That's pretty loud. Okay, let's go to... Okay, so last time we were looking for a scale drawing from each of you, and hopefully you were able to get that done. Let's review really quick what we were supposed to have done for today. You were supposed to take your 3 alternative designs and complete the decision-making process where you use this design evaluation at the bottom of each of these pages to decide which one is your best design, and then to go ahead and start doing the specifications for that design by filling out the worksheets, which are here. So you have the worksheets for wood, plastic, and string and cable or whatever, and you start making measurements, and they talk about how to do that on your drawing. And of course you also want to make the actual drawing itself. In the end you should have, where are those pages at? They're down here. At the end you should have your alternative bridge design sheet, and if you needed to make some adjustments to that, that's fine. But you should also have the wood member dimension sheet, plastic member dimension sheet, and dowel dimension sheet, and cable dimension sheet. And anything extra that's not one of those things, just place at the bottom one of those sheets and tell me what it is that you're using. And they should have measurements and where the holes will be cut or drilled, and where things will be cut. If you need to draw a picture, that's fine. You can add in pages if you need to draw pictures or take pictures. But then here is your here was the page that we used for the layout for the scale, full scale drawing. And like I said before, it's not necessarily going to be full scale because the distance between these black lines here is not exactly an inch. It's actually set in centimeters, but it's not really a centimeter either. And so you print these off and kind of rescale them. I would make each one of these black boxes an inch by an inch, and that's pretty close to being to scale. And then you can hopefully use that to make your measurements and get everything ready for the final step. And the final step here, and of course you do need to turn that stuff into me, so please send that to me. I want to know that it's done. And then the final step is the pre-test bridge evaluation and revision, and then the actual post-test bridge evaluation, the actual test itself. So in the pre-test bridge evaluation and revision, you can see there's 2 pages of things to do, and you put your name on it in the bridge, and I don't know what they mean by set, but anyway, you should include, or you should have a photocopy of your alternative bridge design sheet, colored pencils, and know what you're going to put your bridge on between 2 tables or 2 chairs, or whatever, your bridge abutments, and you should have a camera to take some pictures of this. So take a picture of the top and the side. So this is a real-life, honest-to-goodness picture of the built bridge. So essentially between here, this final design drawing and this post-bridge evaluation, you need to build. So really they should put on here, first thing you need to do is build your bridge. But that's okay. So once you've got your bridge built, take a picture of your bridge, and if you make any changes while you're building it, because you're finding while you're building it that your design is not working for some reason, change those in the drawing. And then you're going to go ahead and write your pre-test evaluation on top of your design sheet, and you're going to put some stress into it. And you can do this before and during, actually. You're going to determine which of your components have stress and tension in them. Tension and compression in them, or no load. And so if you used a computer program to test your bridge digitally, if you did it on a computer at some point, you can get your information from there. If not, you're going to have to kind of make a guess as to what things are going to be stretched, and that's your tension, and what things are going to be squished, which is your compression, and things that will not be stretched or squished, which would be the no load, right? And make a key for that. Then you're going to actually put it on the abutments and put some force on it to see if it see how it does. Just put enough force on it to see it bend a little bit. Just add a little bit at a time. Now, what are you going to use for force? I would recommend that you tie a string to the bottom of your bridge, somewhere in the middle, best if it's in the middle, and hang objects that you can weigh on there. A good option is to use weights from a weight room. So you can get, these little weights, little handheld dumbbells that are only a couple of pounds, and that's a good thing to start with. And just kind of hang them down there, kind of twist them onto the string or tie them onto the string in some way, and hang them from your bridge. Some people try to sit the weights on the bridge, but you'll find that it's hard to find weights that are heavy enough that will fit on your bridge, and you don't want to sit them on top of the bridge, because the top of the bridge is not designed to hold the load. The bottom is designed to hold the load, and it does matter. So start loading the bridge and taking pictures with each load. So you're taking pictures of everything that you do to the bridge. And if you're going to measure how much it bends, how much it deflects, go ahead and measure that. The best way to measure that is to take a yardstick or meter stick and put it on the floor and measure where your bridge is before you put on the load, and then measure where your bridge is after you put on the load, and you can take the difference and get your amount of deflection. So they want you to, after you've loaded the bridge a little bit, to kind of make some observations. Where do you think your bridge is most likely to fail? And they have a list that you can make of members you think that will possibly fail. And if they're going to fail, you might as well improve them before you make the final test. And so you're going to take those ideas and that test and make an improved or revised bridge, maybe add in something, take out something, reinforce something, whatever it is you're going to do. And then go ahead and add those redesigns in and do it again. And you can do this as many times as you want until you think you've got a great bridge, and that's fine. But we do have to try to get this done by Wednesday for the post-test bridge evaluation. So, in the end, they want you to calculate some things like design efficiency, the ultimate load capacity divided by the dead weight of the bridge, because the weight of the bridge does matter. So if you can hold about 30 pounds of weight before it breaks, before something on there completely breaks, then that's your ultimate load capacity, and then you weigh the bridge itself. I would recommend weighing the bridge before it breaks. It just seems to be easier than piling a bunch of pieces. But anyway, you're going to calculate the efficiency using that formula. And then the total length of the materials used. So you're going to add up all the lengths of every material and put those numbers down here, because that's going to be essentially part of your grade. The less you use, the better, unless you don't have a very good load capacity up here. The efficiency will be part of your grade as well. Then you're going to write a concluding report. Your concluding reports can be between 1 and 2 pages. Try not to make it too long, but certainly don't make it too short. And it should include information about the bridge design process and revisions, just kind of a summary or an overview. You've already got all the details in the report, in this entire report that you've done. Then bridge aesthetics you're going to talk about, maybe give a paragraph on why you chose the design you did and why you think it looks good. Bridge efficiency and economy, where you're going to talk about these two things up here, the design efficiency and the total length of materials used. And bridge performance and failure, you're going to talk about how well your bridge did when we actually loaded it. And then one thing that's important is you're going to include how the terminal bridge failure could have been avoided, or how the bridge design could have been improved to support a greater load. You're going to reference, include any bridge drawings and pictures, and you should use these kinds of terms as you're talking in your report, because these are the kinds of things that engineers would talk about with a bridge, and we want to try to give you some engineering experience. At the very end of this post-bridge evaluation, you're going to give yourself your own grade. The first line here is for you to grade yourself, based on design criteria, performance, aesthetics, craftsmanship, student participation, drawings, and sheets in your report. Notice that some of the things that we've done here are going to help you with that. For example, if you go here to meets design criteria, performance, you can come up here and you can say, well, performance of my bridge was good because Actually, somewhere here it should say, well, anyway, in your final report you're going to talk about where it failed, what load it failed under, so you can use that to decide whether it meets design criteria. If it failed under 8 pounds of load instead of 10, then it didn't meet the design criteria. Don't give yourself such a great point here. But if it failed right at 10, you probably don't want to give yourself perfect points, because engineers almost always over-engineer a little bit. It should be able to hold more than 10 without breaking, even though it's not performing as good as it could. And if it holds maybe 15, 20 pounds, then maybe you give yourself a perfect score here. Performance, of course, is going to have to do with deflection, and it's also going to have to do with this meeting design criteria and anything that starts to crack or break. Aesthetics, how good, how nice do you think it looks? Craftsmanship, how well does your built bridge conform to what you drew on your drawing? Compare the two. If the drawing is nice and straight and even, but the actual bridge itself is a little crooked and wonky, then you're going to not score yourself so good here. Student participation, do you feel like you put in the time and the effort? Drawings and sheets, you're going to look over your drawings and sheets and see if you think you've completed them well and cleanly and done them all the way through. And then, of course, you're going to give yourself a grade on your report for a total of 100 points. You're going to give yourself some number out of 100. And I will do the same. I will go through and look at what you gave yourself, and I will look at your completed worksheet with the report, and I will give your project a grade. So these are the two things that you're going to do: the pre-design and the post-design. Of course, the pre-design is going to include the building of the bridge, and so that's no small deal, of course. But we are coming to the end of this project now. You may be wondering, how are you going to test this if you're not here? You're going to do it on your own, and you're going to make a video of your test. So for this post-test bridge evaluation, when you get to the point where you're actually testing so you can get your numbers for your final report, I would like for you to put your phone on video mode, or borrow a video camera from someone at the school, or put your computer on video mode and point your computer at it, and find some way to record a video of your test. I will accept still photos, but I would prefer a video. I'd like to see what's going on and hear you talking, just kind of have a little more live connection. But in the end, I would like to see, probably take maybe 10 minutes of video where you're putting your bridge between two tables. You're going to measure the distance between the tables to show me that it's 24 inches. You're going to measure the distance to the floor from the bottom of the bridge before you load it, so we can measure deflection. And then you're going to start to load it, and you're going to read deflections off, and you'll keep loading it, reading off deflection, keep loading it, reading off deflection, and telling me what kind of weight you're putting on. And you're going to keep doing that and taking data until the bridge fails. So and sometimes, I mean, I've actually had bridges that have not failed under the available weights that we've had. So that can happen. I wouldn't put more than 50 pounds on your bridge while you're testing it. It's a little overkill, but give yourself a good amount of weight over the 10 pounds we've asked for. So, if you have any questions about this, since we can't really talk to each other, then you'll have to send me an email or give me a call, and you can ask questions. For that reason, since we're coming to the end of this project, I will go to my office so that you can send me emails and ask me questions, and I can answer them easily. From here, I can't answer phone calls very easily, even though I can answer emails. It's not as easy here. Before I leave this classroom, I will also go to our schedule here, because we need to talk about our schedule a little bit. We're a little bit behind. So if we go to our syllabus for Engineering 1000, 1215, we originally had in our syllabus for today, which is the 21st, Monday the 21st, this would be our last day of the bridge project, and we would start Chapter 5 on Wednesday. But I think that since we're going to be finishing up the project on Wednesday, hopefully, that we will start Chapter 5 on Friday and continue it Monday, and then the next Wednesday, a week from this coming Wednesday, we have scheduled Exam 5, but I will probably just give you the exam to take home again, or to do on your own, and we will spend Wednesday the 30th working on the rest of Chapter 5 before our next problem-solving project. And the next project is going to be one that's a little bit more involved with creativity. The bridge project, we're using a lot of bridge designs that have already been used, a lot of established engineering principles, so we didn't really have to be very creative necessarily. We just had to go out and find out what had been done. But this next project, I'm going to challenge you to try to be creative, because we're going to build a rubber band car that is going to drive the longest time for the shortest distance, or the shortest displacement from its original position. And we'll talk about that more at the end of next week as we get closer to it. It's something to start thinking about creatively. Using the parts that you have in your building kit, can you build a car that is rubber band driven and starts at one point and ends up as close to that point as possible, but takes a long time to do it? And that's kind of a big challenge I've discovered over the years. It's not one that's easy for the students. So that is where we are. Like I said, I'm going to go to my office, so if you have any questions, send me an email, give me a call, and we need to talk to somebody to get the sound working. I don't know why it's not working. I don't think I have much control on this end. But we will figure it out. Have a good day. I will see you guys on Wednesday. Don't forget to email me if you have questions.